Welcome to Code the Future, where we sit down with the innovators, leaders, and big thinkers who are driving our software-defined future. Today, we're sitting down with Robert Thompson, Director of Edge Processing Ecosystem at NXP. Robert, welcome to the show.
Great to be here, Matt.
Excellent. So, NXP, one of the biggest players in the semiconductor space, maybe not a household name like Coke or Pepsi, but I think many of our viewers and listeners would be astounded to realize the sheer amount of things that NXP powers in their day-to-day lives, whether at work, personal, whatnot. But before we get into NXP's business, maybe you could tell us a little bit about your background and what sort of sparked your passion for the industry.
Sure. My background is a little varied, actually. I'm not your typical semiconductor engineer. I studied science at college. I then worked in a range of technology and consulting roles. And then I came to semiconductors with Freescale in around 2010
Okay.
on the marketing business development side. And then I've really grown in and really grown to love the industry and what we're attempting to do.
Yeah.
Obviously, Freescale has changed into NXP, and we've grown and adapted with the market as we move forward.
Yeah, gotcha. So maybe you can provide a bit of a bird's eye overview of NXP's business and the different sort of trends that are driving your growth and whatnot. Yeah.
So as you mentioned earlier, NXP is a very broad company. Everybody probably touches or interacts with an NXP product without realizing.
Yeah.
So about half our company is focused on the automotive market. So we're one of the biggest suppliers of semiconductors to automotive, and that's where traditionally we've interfaced with QNX the most, with the automotive business. But apart from the automotive business, we also have a industry-leading role in mobile payments with NFC tax, networking and infrastructure, including 5G, and then the area that I focus most on, which is industrial and IoT. So those are all extremely broad markets. So obviously, we talked about automotive. So we all interface, or most of us work with cars, autonomous vehicles, drones. All of those are expanding into that or growing in through that space. But if you look at mobile payments, obviously passports, payments, we all interact every day with some form of mobile payment or mobile identification. Obviously networking and communications, we all carry a cell phone, so we're all interacting with a network of some type that is powered by NXP. And then obviously industrial and IoT, that covers everything from factory automation, healthcare, building and home automation, and then power and energy.
Gotcha.
So really, we are the basis and touch almost all industries that use semiconductors.
Yeah. Really soup to nuts, right? Like every industry under the sun, right? So when you think about the future, though, are there particular subsets or of those industries that you see the most potential from a growth perspective, or?
Well, I think one thing that we see is that, if we've talked about these four areas, and traditionally they've all been very distinct and siloed. If you look at 10 years ago, the automotive industry didn't really have a lot to do with the industrial market, at least from a semiconductor perspective. Mobile payments and communication infrastructure, they were all very unique. I think as those markets grow, what we're seeing is the merging of usage models and needs, starting with software, to be very honest. If you look at the automotive market, the software-defined vehicle is obviously here and very present and a very well known and used term.
Yes.
But if you look at where we're going in other markets, in terms of the regulations that are beginning to impact them, be it the Cybersecurity Resilience Act in Europe, the SBOM in the US for FDA and healthcare, we're seeing a lot of requirements actually merge across these different markets. So to answer your question, there's growth everywhere. Obviously, growth is not even. And year to year, that growth can vary. Last year, a number of markets we play in were down. Others were up. So I think the way we view the world is that because we're so broad, financially it helps us when one area is down, the other is up. But I think the other advantage we see is that a lot of the underlying technology, the software, is now bleeding into each other's market, so we can use the knowledge from one area to help us understand the
other. And really not putting your eggs in one basket, right? You guys are in the fortunate position that you play in so many different spaces, so that, to your point, if one industry is down, you can count on another to pick up the slack, which I think bodes really well for you guys. Yeah. And you mentioned sort of, automotive or software-defined vehicles sort of being that tip of the spear that, you're now seeing a lot of those same trends in relation to the different industries or whatnot. Obviously, there's been a ton of challenges when it comes to the development and mass adoption and acceptance of software-defined vehicles. Are you seeing those same sorts of challenges across, say, industrial automation or medical devices? Are there different challenges depending on the industry, or you see it sort of one and the same?
Well, I think the one challenge is that as everything becomes more connected, out of both customer needs and regulatory requirements, enhance the capabilities of the product, but you also increase the vulnerabilities.
Mm,
So, as we become in a connected world, you have a lot of benefits in the,
yeah.
let's take the medical device manufacturers that we
Yep.
work with and QNX works with as well. 10 years, 15 years ago, most of the devices that we were in, healthcare monitoring devices, were not connected.
No.
If they were connected, it was a hard connection through Ethernet.
Yeah.
Now, if you look at the next cycle, it's all connected through a variety of connectivity into protocols, be it Wi-Fi, be it Bluetooth,
Yeah.
be it low energy. So you add a lot of flexibility. You can update over the air. You can add features. You can add you can monitor remotely. You can collect a lot more data, but you're opening up a lot more vulnerability. So
Exactly.
underlying features such as safety and security become more and more important and
Yeah.
prevalent and go from being really a nice to have maybe 10 years ago to critical in terms of defining the product and
Yeah.
making that product can not only be successful, but actually get to market and meet all the government regulations, which are now impacting many vertical markets that we play.
Gotcha. So maybe you can talk a little bit more about, the importance of functional safety when it comes to mitigating the risk of systems failures so that, obviously there's a ton of connectivity. There's a lot more things that can go wrong. I mean, how does NXP make sure that, manufacturers are building the safest devices possible?
Well, we provide the building blocks. And so what we're doing with our latest products, in the past, what we've had is we've developed the ability to create functional islands, functional safe
Right.
islands. Right now, what with our next generation of products, we're actually creating the products from scratch with the ability to meet all the functional safety regulations, which are either prevalent today or coming in the near future. So what we're doing is we're going out and instead of saying you can make this functional safety compliant by doing this, we're actually building the hardware building blocks into the device.
Mm,
If you look at what's happening in Europe and also the US, where government regulations go is anybody's guess,
yeah.
and it's not good to predict.
Yeah.
But really, what we're doing is we're building our devices with the ability to meet all of the functional safety requirements that are on the market today and what we believe will happen.
Yeah.
And therefore, I think what we're saying is because you have the ability in the fundamental building blocks of the device, you might as well utilize that and build it from the start, knowing that you can then add functionality and capability to the device during the life cycle of the product.
Yeah. Yeah. Gotcha. Best prep for the future, if you will, right?
Yes.
So I want to pivot quickly to, I mean, you can't have a conversation about technology without talking about AI. And I know you guys are heavily involved in terms of AI at the edge with a view to enhancing IoT applications. Talk to us a little bit more in terms of how you look at the technology and where you see it going in the future.
Great question. How long do we have to answer that?
As long as you want, as long as you need.
So I think the reason I say that is because, we started off by talking about how broad NXP is.
Yeah.
We have
Pick an industry, medical.
well,
Or,
I think you see, the way we look at it is we play at the edge. We're an edge company, right? We don't play in the cloud.
Yep.
So we're looking at how do we deliver devices that meet the needs of our end customers without burdening the silicon with features that most of our customers will not use. The challenge is obviously most of our product life cycles of our customers are 10 to 15 years. But what we're really doing is not trying to chase the market and chase some companies, very well-known companies, that are really leading the AI space. Because when we talk to our customers, most of them are just beginning the journey.
Okay.
Now, obviously, some are very advanced. already understand what AI and machine learning is for them and their end customers.
Yeah.
But most of them, to be honest, especially in my space, industrial, they don't really know, and they're looking for us to give them guidance of where we think the market is going.
Yeah.
So if you look at the products we're bringing to market and have already brought to market for many years, we have neural processing units, which are designed specifically to run the models that are in the most efficient way at the lowest power.
Yeah.
But we're not burdening our chips with so much silicon, that will really drive the price up for a very small percentage of customers that will use it.
Who won't even use it. Yeah.
So what we're trying to do is right-size our implementation, where we give people the ability to have AI and machine learning at the edge. But what we don't do is burden them with products that are higher priced and higher powered when they don't really need that right now.
Yeah.
Now, we also, having said that, we just announced our intention to acquire a company called Canara. This is not closed yet, where Canara are a company that have specialized in the development of chips specifically to run machine learning at the edge. So what we can do, and initially, if we do have companies that look at our products and say we need a lot more performance, TOPS is the most commonly used term, although now that's been subdivided into sparse and dense TOPS, and that's why we really try and keep away from speeds and feeds, is we can say, we can offer them Canara, and we can integrate that chip through an M2 connector or a different connector on the board. So we now have the capability, assuming this deal closes, to offer some customers that really are pushing the boundary of where AI at the edge are. We have a solution in-house, and they don't have to go to a third-party company.
Gotcha. Okay. No, I mean, that sounds like a really sound strategy and the right approach, right? So,
well, we'll see. Today it makes sense.
Yeah, today it makes sense. So, I mean, you talk, we'll see. When you think about the future, I guess, and NXP's business, all the different spaces and industries that you play in, what are you most optimistic about? And what, I guess, keeps you up at night, or what strikes the most fear into you in terms of where the business is at and your current technology roadmap and whatnot?
Well, I think what inspires us is the edge, right? I think what we see is, obviously, if you look at computing performance traditionally and the ability to do a lot of complex tasks happened in the cloud. And the edge devices were often simply seen as collecting the data and passing it to the cloud. I think with the evolution of data networks and the importance of running, we were just talking about machine learning, running models at the edge for a number of reasons, for privacy, for security, for safety. What we've seen is our customers coming and asking us to be able to do things at the edge that 5 years ago they were doing in the cloud.
Right.
So obviously, what excites us is the capability of what an edge device can be. And an edge device is an automobile, is a robotic arm, is a medical, is a healthcare monitoring system.
Right.
It's extremely diverse what it can be. And that's what really interests us, the capabilities and the possibilities of where edge can go.
Yeah.
Now, what keeps us up at night is that same possibilities, where we go back to the vulnerability.
The double-edged sword.
Yeah, when everything is interconnected through many different connectivity options. Once you add connectivity, you add attack vectors and vulnerabilities. So how do we make sure that as we deliver more functionality and capability to the edge, we do it in a safe, secure way? Which is why we need to work with companies like QNX.
Yeah, I was gonna say, and it's a good problem to have, right? Because it keeps you busy, and the job is never done, right? So you'll always be in a job to try to strike that balance.
Hopefully,
well, walk that line, right?
Yeah.
So talking about the next generation, the people who the kids who are now kids who will be building the software-defined vehicles or surgical robotics or industrial automation equipment for next generation factories, what do you see as the critical skill sets for that next generation?
I suppose I could say software.
Yeah. That's a pretty broad
to please the crowd.
Yeah.
No, it's a good question, and I don't think there's one answer. I think as we've started talking about automobile and the software-defined vehicle,
Mhm.
the underlying IP that goes into that is obviously fundamental.
Yes.
So I think what we've seen in the last few years is a swing from obviously when the AI revolution started, a lot of companies drove that. But really, those companies that were driving it still need companies like NXP to build the hardware that it's based on.
Mm.
And so I think it's, as always, a really broad skill set is key. Your skill is still going to need design engineers, even if it's AI assisted design, just like with coding. If, the amount of coding might, go down in terms of the number of people needed because of AI assistance, but you're still going to need people to define products and design both hardware and software, which are differentiated and meet the ever changing needs of the end customer.
Yeah.
So I think, even in a company like NXP, if we look at our hardware product group, we actually have more software engineers than we do hardware engineers to maintain the software board support packages that we develop. So it's really, you can't focus on one. Even if your focus is software,
Yeah.
you still have to interface with hardware. You still have to understand the needs, what the trends are,
Yeah.
and vice versa. And so to me, you have to approach from a system level. Look at what is the key features and functionality of the overall system.
Mm-hmm.
What hardware IP blocks are needed to
Mm-hmm.
develop that?
Yeah.
How do you stitch those IP blocks together in a form factor and power envelope that meets the overall system needs? And then how does software enhance, take that capabilities of the hardware acceleration and develop a complete software stack, which is both meeting all the needs of the end customer, but also secure
Mm-hmm.
and safe.
Gotcha. No, great insights. Always our final question.
Yeah.
If you could give your younger self a piece of advice, think about back 20, 25 years ago, you're starting out in this industry, what would it be and why? Knowing what you know now.
Yes.
Get into AI.
No, I think in the end, it goes back to the customer, right? It's understanding customers' needs and how they evolve and how to interact with customers. Because we all know that, AI is here to stay. How it will evolve and how quickly it will evolve in the industries we play in
Yeah.
is still a big question.
Sure.
If you go back a few years, I was at CES, and you would have thought by now everything we interacted with was voice enabled.
Right.
We now know that didn't happen for a number of reasons. So,
Or autonomy for that reason, right?
correct.
Yeah.
I think, as we all know, technology always takes longer to go down that
Hype cycle.
hype cycle and come out the other end. But when it does, it tends to happen very fast. So I think it's, in the end, it's what the customer needs are, and how do you build a product or a spec sheet which will meet those needs. And, it's easy to get caught up in hype. But I think machine learning, like all the other technologies, will become a critical part of our products, be it automobile, industrial, telecommunications. But it has to be around the rest of the features and functionality that makes sense to the end users.
Gotcha. So staying on the cutting edge of the customer's needs, and you'll never go wrong, is what you're saying.
Yeah, it's interesting you use cutting edge because, we don't think, if you look at a lot of our industries, they're not cutting edge,
Yeah.
right? But what they do is they take a lot of technology and incorporate them in a way that meets the needs of their customer base. So if you look at the medical industry, in some ways it's very advanced, but in many ways, because the products are in the market for so long, you have to make sure that you're incorporating technology that is not going to be here for 2 years and then disappear. Is going to be a long life cycle of 10, 15 years.
Fascinating. Great insights. I really appreciate you making the time, Robert.
All right.
It'd be interesting to see where it heads next.
Yes. Great. Well, thanks for your time.